Hello and welcome to our presentation. In this presentation, we will walk you through the different aspects of our open research project to improve transparency and consistency of diabetes research with electronic healthcare records. We are part of the Exeter Center for Diabetes Research, and the group's mission is to advance the understanding of diabetes, its causes, and its effective treatment through the use of innovative statistics, artificial intelligence, and data science methods. One of the major data sources we are using for our research are electronic healthcare records, such as from the Clinical Practice Research Data Link database, which represent around 6% of the UK patient population.
So, electronic health record data, such as CPRD, is collected for the purposes of routine healthcare and not for research. However, it can be very valuable and is becoming increasingly popular for research. This sort of data is very messy, and getting it to a reproducible and analysis-ready dataset is challenging and time-consuming. The data processing required is often repeated again and again by researchers in the same field or even within the same research group. Therefore, we have implemented a number of open research practices in order to ensure our work researching diabetes using electronic health record data is as reproducible and as transparent as possible. The first challenge we encounter with the data is that everything is stored in the form of codes. This is an example of just a few of the codes that can indicate diabetic retinopathy in our CPRD dataset. These code lists don't come with the data, and so we have to put them together ourselves. Therefore, we developed a flexible pipeline for generating these code lists. I won't go into detail, but a key part of this process is that each set of codes is validated by a clinician. And the end result is a list of codes that we can use in our data, ensuring consistent and robust variable definitions across our projects. We also made sure that this process was generalizable to other GP datasets as well as just CPRD. We've also shared our process and all the code lists that we've put together online in a public GitHub repository, where anyone can access them, alongside the phenotyping algorithms we've also derived in order to implement the code lists and to define variables. Sharing this online allows other researchers using CPRD to benefit from this work. We've also developed a reproducible data processing pipeline to build diabetes cohort datasets. The pipeline starts with defining a cohort of everyone in our data with diabetes and their static features, for example, their ethnicity and diabetes diagnosis date. We then specify the index date we want to use, for example, the date of diabetes diagnosis, and define biomarkers, comorbidities, and other features relative to the chosen index date. The output of this pipeline is a standard cohort with baseline features as well as certain outcomes. And these datasets can then be used to answer different research questions. For example, what features of diabetes diagnosis are associated with rapid insulin treatment initiation? The R scripts that make up this pipeline have all also been shared online in a public GitHub repository, alongside lots of descriptive information about what each script does and data dictionaries of all the variables in the output datasets.
Another element of this project is the organization of our research output in GitHub. GitHub is a code hosting platform which enables us to use version control of analysis codes and reduces the complexity of working together on the same codes. Our GitHub organization allows researchers outside our department to access all the code lists we have generated for CPID and our bespoke implementation algorithms. We also share our code to define cohorts and run the analysis for ongoing projects and published papers, allowing our work to be transparent and shared beyond the group. This GitHub organization includes the two repositories which I've previously mentioned, and additionally includes repositories for air packages developed in our group. Alongside our GitHub organization, we organize regular training sessions for using and promoting open research practices. We have conducted workshops in our team to help especially new users get started with our GitHub organization. The main topics of our training sessions include the use and aims of coding with version control, the GitHub workflow, consistent coding throughout the group, how to publish analysis outcomes and codes, and data safety. All our training materials are also openly accessible on the GitHub repository.
So some of the benefits of our framework is that all the information is present in one single repository, where we avoid unnecessary repetition of work by multiple researchers and ensure consistent coding throughout our team and projects, with all the extra time being spent on analysis. It improves, but also ensures transparency in our research. The documentation created during the development process helps new starters get up to speed fast, ensuring that all the information needed to work in a certain project is there. The same documentation then facilitates the approval process for CPRD protocols, since we're able to show that the process we have in place for cleaning and analyzing are robust. Lastly, the public availability of all of this information encourages collaborations between research groups, which has already sparked interest from outside the university, and we've been contacted regarding other applications of our codeless framework. Alongside publicly available scripts, when warranted, we release online research tools that can aid practitioners with the newest and latest models available for supporting classification or treatment decisions. So now future steps. There's a lot more that we have planned to do. First, we want to expand the current training workshops to include a workshop on data cleaning and cohort coding processes. We'll workshop on using GitHub for the version control and sharing code within projects, and a workshop on handling data safely without breaking potential anonymity rules inherent of the data being used. We want to create training for new team members, which will expand on topics mentioned, but also provide a reproducibility code of conduct, which should maintain the vision of our framework. And lastly, we want to create an open access cohort profile, a manuscript that will include all the description necessary of the dataset we are using, but also a breakdown of all the data processes that occurred, which could be implemented by others in other projects. Something that we're currently working on and should be out soon. So in summary, we've led the initiative in our research group towards an open and reproducible research, including practices such as creating reusable pipelines for building datasets and code lists, publicly sharing our code lists and code for data processing and analysis, and we provide training on open research practices to others within the Exeter diabetes team. These efforts continue to benefit our own research and others in our team, as well as the wider community of CPRD. Thank you for listening.